Please note all of these videos will be using the lecture material and the sheets provided to you on the Moodle page. Let's begin. We are interested in, as we said in our introduction, a series of transitions. And this is part 1. And what we're looking at part 1 is, use a different colour, the limits of what you call procedural programming. And this is the way that we have been programming in the unit so far. We've been using a technique which is essentially a series of procedures, and we create new types of procedures in new types of blocks. So, for example, typically what you've been doing is you will recognize the use of that word, the name of some function. Sometimes you give it some values in here, a colon, and then you write some lines of code here. This is the way that you've been organizing your code into small chunks, right? So we've been organizing the code into small chunks and linking these various different chunks or pieces together and using the command prompt and writing the name of the function, for example, and running it in that kind of way. So the first point to note is that this concept, this idea of def and this function with something and a little block of line is the basic unit we've been dealing with when we've been writing our code so far. Now, what I'm interested in is to select an example. And the example I'd like to remind you of and use as the basis of how we're going to explore this transition is the stick figure. What you had in the previous semester was building this stick figure out of different parts and then drawing it, colouring it, and in some cases doing other more interesting stuff with it to it. So it is, as you can see, it's made up of a circle here, and it's made up a whole bunch of lines, right? And the difficulty that you had, and there's a line, the body's a line. The difficulty we had when we were coding, or difficulty anyone had with this, was really actually just mathematical. So it was the position of where these lines were. Okay, so you know, where is this center point relative to that distance there? Where do I place this relative to that distance? How long is this distance here? Where's that point? And so on. And so essentially drawing that was a whole bunch of numbers thrown into code which would create lines and circles and draw them. So the code looked a bit like this. You had the def, and then you had a piece of code called draw stick figure. Bracket, you didn't give it anything. Then inside here you would do things like this. You would have a window using graph win, capital W, and a whole bunch of stuff you drop in there, the size of the window and so on. Then you would create a head, and the head is a circle, and you built that out of creating a circle and passing the circle some point and then a radius value, and so on. Once you built all your parts, your legs, your arms, and so on, you would then draw the object. So you would have code like this. You would draw it. And we use the window we created up here. So this was used also in an int prog test, but it was also the basic way that you coded. And the critical thing to note is that the way the code is organized is simply through, let's use a different color, it's through this pattern here. We had a def, we defined what it was at the top here, and inside of the instructions of how to build and draw our stick figure, and then when we wanted to use it, so in order to execute the code, we would have a prompt and we would write draw stick figure. So this is really going back, and we'd hit enter here, and then it would pop up the window and hopefully draw our stick figure and do any adjustments. Now this is basically how we coded. So this should be nice and familiar. Go to the worksheet and you'll see the code. You've also got the sample code on the Moodle site for you to play with, and it's very important for you just to be familiar with it. Let's just draw out one issue which we want to try to solve. And one of the issues was this code had so many numbers everywhere, and the issue with the numbers was that they hard coded the location of where you were drawing this particular figure. So let's begin by resolving that particular problem. We did this in several different ways. The most common way was to imagine an invisible rectangle, and this top left hand corner, which we will say is the crucial point here, and then we would see our stick figure occupying, really badly drawn of course, the space inside here. I'm just going to fix it across like that. Okay, what was crucial and what was interesting about this way of resolving the hard-coded, now what the problem we're trying to look at is we've got hard-coded numbers everywhere, and we want the flexibility to draw this stick figure anywhere, okay, to make it relative to this point here, which we will call point 0. Now, that doesn't really look like a 0. But we'll call that point 0. Perhaps in these videos I'll use a subscript, and you'll see in the worksheet I use a big O. I don't use a subscript, but hopefully that won't create any confusion. What we're interested in is we have that point. So if you supply that point, we can draw that whole stick figure in relation to it. Now, several of you, and I'm hoping nearly all of you who attempted the coursework, will have found this way of coding very, very basic. So what this ended up doing was changing our code. So let's just very briefly indicate what that might look like. So if we go back to, we had the def draw stick figure, which I should have actually just used a smaller version, colon, and I'll only take the head, but in the notes it spells it out for every single point. Typically we had, the win equals graph win, line, okay, and so on. I won't worry about the detail here, but the bit I'm interested in is that if you click on the mouse and you pass that value in, bear with me a second, I don't think the 0 works here very well. In the notes, the code's going to look slightly different. I'll just use a P to represent the point. If you wrote this line of code, you click your screen and it calls a function called getMouse. So this line in red was a way of clicking on the canvas or the screen and putting the detail of that location into this point here. Then from that point here, we could pull out the x distance, the horizontal distance from our point. Maybe we'll just use a little O there, that'll be easier, by calling getX. And we do the same thing with the y. I'm not going to write that out because it'll distract us. Okay, so we would get the mouse, we'd get the x and y value, and then we would take these two values and we would add them to every single point when we come to drawing the figure. What do I mean? Let's have a quick look. So for example, you had your head, which was made from a circle. And what it did previously was it used a point, and it hard-coded a point, and it had a radius of 20. So what we did is into that point there, say in that point you currently had the values 30, 50. I'm just reading from the sheet. You can see these values in the sheet. Oh no, I had 30, 30, sorry. Bear with me a second. Let's just scrub that out. On the sheet I've got 30, 30. Right? So that point is hard-coded at 30, 30. And that's the problem. So, you know, down and across are both values of 30. So it fixed it relative to the top left-hand corner of the canvas. So we wanted to shift that point relative to anywhere I gave you. And the way that we did that is that point, if I just grab that bit of code so you can see it, that point, my pen will write, took my x0 value and was added into that 30, and that y0 value and added into that 30. So what we did is we did this, and we add this to every single point inside that code. And what that meant was that you could draw your stick figure anywhere. And I mean anywhere on the screen. So if I clicked my mouse here on the screen, imagine that invisible rectangle, I would be able to draw my stick figure there. If I clicked my mouse here, using that bit of code, I was able to draw it over here, and so on. So this point here, which I've nicknamed point 0, was the absolute critical element in giving me flexibility of where I wanted to draw. So now what we've ended up doing is we've created a situation where I have values which help me create my object. So if you look at the code and you look at the sheets, I talk through some of the examples and how you can create several different, you can create a loop, and I'd ask you to go to the sheet and look at the sheet. So look at the sheet, look at the examples of code and play with them. So in one of the examples I have, you click on the mouse, you draw your figure, you click somewhere else, it's stuck inside a loop, and this is on the same material, and so you can draw this stick figure in lots of different ways and as many times as you like. That's really quite useful. But the problem here, I suppose, is that we still have quite a messy setup. And let's explain what we mean by messy, and we will stop at this particular point by just highlighting one of the issues with the way that the code looks. So to round off this video, what I'd like to say is that there is a concept of messiness at work here. And you might think messiness seems a very subjective and very personal approach, but actually a really crucial thing here is that the way that you implement your code, you know, how you write your code, the lines of code, and the concept of what the code is doing, it all gets muddled up together. It all gets mixed in together. Now, when you're coding with functions, you can try to separate it out by creating functions which use other functions. One strategy, a very common strategy, if you have a series of functions, so let's say I have function here 1, and then I have another function here, function 2, I can, you know, and inside function 1, the code inside it delegates some of the work. So there's some lines there, and then suddenly I use function 2 inside there and give it some stuff, and it gives me stuff back. So I can delegate, just as you would if you were in a business splitting up a big department. You can delegate some of the activity which you have in one function into another. And so you create these smaller functions. Some of you have attempted it. It's a very, very common practice to split up and delegate this function to do this bit, that function to do another thing. Delegation, this concept of delegation, basically creating pieces of code which will do stuff for you and allowing you to pass the responsibility on to that to do it, is a very, very important concept, which will come back much later. So let's get back to the problem of this messiness again. The way that you might want to separate out the way you implement code, and you have details and concepts and they're all modeled, you want to separate them out, is this idea of delegation and lots of different functions and lots of little these def statements. So have a look at this as a simple way, because this is going to help our thinking. Now we had our def draw stick figure function, and if you remember, inside this we had our, let's use a different color, win, and our graph win stuff. You know, we create our canvas and so on, right? One really, really simple thing to do was, instead of, and what we had before was, you would have a bit of code which said head equals, line equals, and so on. What happens if we simply said, let's create one function, right, which will receive x and y, and we call it get points, right? We pass it the canvas. We'll come back to what that's doing in a second. And we pass those values into another function called draw figure. We pass it the window, and we pass it the x and the y. So what's going on here, and what is the point of what I'm trying to say? The point of what I'm trying to say is that it's somehow easier to understand this code because I've split it down into these functions. Function is a bit of code that does something, right? This is your DEF. This is the def use of this. It's a little bit more than that, but for the time being, that's simple enough. If I create my window, I click my mouse, but I use a function called getPoint. So I know what's going on over here. I'm passing it the window. It gives me back these x, y. I then pass them into a function I've created called drawFigure, pass in those details, and executes. Now it's easier to read this code. This code is essentially a bunch of concepts. First concept, create your window. Second concept, let's highlight this, right? So your first line of code is one concept, create your window. Your second is get your position. And your third is to create the object. This is a very, very desirable way of making your code look. So the concepts are clear at the top level or when you're using them. And bear in mind a concept that comes into play quite a lot. You might have heard this in networking contexts of a client, which I've, actually let's rewrite that so you can see that a bit clearer. So you have an idea that there is something called a client or a user, right? And you have an idea of something called a server. And this distinction is actually really useful because the server is a broad way of saying these are a bunch of functions and bits of code that do stuff. The client or the user in this context is just about using what you've already got there and taking advantage of it, combining it. So what you see here on this screen with these three lines is that get points would be something that serves us, right? It's something that exists. Draw figure is something that serves, that I'm taking advantage of and using. So over in the client, I'm literally assembling code by concepts. I need to create a window, so I'm using the graphics and graph win. I need to get the point, so I've got a function. I draw in called get points and gives me back this. And then I need a bit of code called draw figure, which will draw me my stick figure, right? Based on these three pieces of information. These distinctions and ideas are really, really very valuable and important. What I'm going to do now, excuse me, is finish by showing you a way of splitting something up into logical pieces, right? Now, this should make you just simply remember what you did, hopefully a lot of you, in your stick figure. And it will also help you appreciate where the limits were. If you have a function called draw head, and inside there you pass it the window, the x0 and the y0, and inside there you have your code, which is all about you create your head object, circle, and you fill in all the details based on these numbers here and a radius. Then you do a head draw. And this code is all available to you. Then let's just, for the sake of argument, let's just have a look at def get points, just so you can see a sample of what I'm talking about, because you may not have the sheet in front of you. You pass it the window, and inside this code you have a point 0, which you do from a window.getMouse, and you create the x0 from the point, and it's the getX, etc. And then you return, this is a really important idea, your x0 and your y0. Okay, bear in mind how useful this is. So what we have is 2 chunks of code, and we have many more. Just go and look at the worksheet. But what we've done is we have followed through an idea, and this idea many of you will already have used and encountered, that you split down a big function, you end up very usefully passing in values and operating on those passed in values to do something, right? And when it turns into a function fully, you not only pass something in, but you return something from it. So this is now fully a function, and functions are incredibly useful. There is something called functional programming, which is not just this. This isn't functional programming. Functional programming has other concepts attached to it. But this is the beginning of a function. So let's just, before we finish this, let's just kind of codify that concept, right? For this to be a function, it receives a bunch of values, which I will call parameters, right? It then operates on those parameters, and then it returns some return value. Now, this is the structure of a much more useful way of writing procedural code. And what it allows you to do is you don't just delegate. Here, you aren't simply just delegating a job and passing a piece off. When you delegate at one level, you create subroutines, right? But what we're interested in here is not just splitting the code up so different parts do different things, but we are interested in passing stuff in and getting values back. This is much, much more useful concept to us. So we find that good procedural programming ends up using a lot of proper functions. Now, I was very ambiguous when I used the word function earlier, but so we have to draw a very slight distinction to finish off this video between a subroutine, which is just a routine of code, and functions. So that's kind of been very, very helpful. And what we're going to move on to is a much more detailed criticism of the issues involved here, because that will lead us into what we need to think about, where the challenges are.